Hello, and welcome to a very special modular live stream introducing Max 25.1. I'm Caroline Frasca, Modular's community manager, and I'm thrilled to be joined today by the fantastic Modular team. Today's event is focused on digging into everything that makes our most recent release, 25.1, so exciting. Before I get into the agenda, a quick request for everyone in the audience. Let us know where you're joining from in the comments. And if you have any questions at any point during today's event, leave a comment and we'll answer you during Q&A at the end of the session. So with that, let me run you through a quick agenda for today's event. First, we'll hear from Modular's co-founder, Tim, and head of product, Eric, for a quick intro to this release. Next, Brad is going to give us a deep dive on our Max updates, including a demo of the new GPU programming interface. Abdul will highlight what's new in Mojo 25.1. Asan will cover Max builds and how to get started with recipes. And then finally, the whole team will answer all of your burning questions together at the end of the event. So without further ado, I'm going to hand you over to Tim and Eric.
Hey everyone, I'm Tim Davis, one of the co-founders at Modular, here with Eric, who leads product, and we're thrilled to announce today our latest release, Max 25.1.
Thanks, Tim. Hey everyone, this update marks a huge step forward in our approach to delivering next-generation AI infrastructure for the world.
Alrighty, so to start, we're introducing a new product surface called Max Builds, a hub for Gen AI models, application recipes, and community-driven packages. We're still early in expanding our coverage here, but this is now your go-to place to start building with Max, with models supported on CPUs and GPUs, all the quantization schemes, complete workflow recipes and packages from our community. So go and check it out, give us some feedback, and start building with Max.
Thanks, Tim. So now on to Max 25.1 itself. So the first set of improvements focuses on high-performance LLM workflows. 25.1 introduces both prefix caching as well as page attention to reduce latency and optimize memory consumption. The second set of improvements focuses on enabling agentic and RAG workflows. We've added support for the MP-Net2 embedding model. We've also added support for structured and constrained output generation, ensuring that your LLM responses conform to the exact API specification that you have. And finally, we're also introducing an OpenAI compatible function calling API to give you an industry standard way to interface with external tools and services.
Awesome. And lastly, to increase the pace at which you can develop with our platform, Max 25.1 marks a fundamental shift in how we deliver updates to the community. We're moving to a nightly first approach, ensuring that you always have access to the latest improvements as soon as they're ready. As always, your feedback helps shape the future of what we're doing, so please keep it coming. Join the forum or the Discord. We can't wait to see you and see what you create with Max 25.1. Thank you.
Thank you so much, Tim and EJ. Now you're going to hear from Brad, who is a product manager at Modular, and he's going to go even deeper on the new updates to Max. So don't forget to leave your questions in the comments so we can get those answered at the end of the session.
Hi, I'm Brad, and I'd like to show off some of the major new additions to Max in 25.1 and kind of answer the question that's on the screen. What's new in Max? A lot. So this release is full of new AI models and new capabilities. We'll get into each of these in detail, but as a quick overview, in Max 24.6, we unveiled our initial preview support for GPUs in Max. And we're following on from that in 25.1 with a new interface for programming GPUs using Mojo. We're providing new capabilities for building AI agents. In 25.1, Max now supports multimodal models that can take in images and text. Embedding models have also been added to the roster, including the ability to perform offline inference with them. And finally, we've made it even easier to get and use our AI models with a new command line tool. So to start, talking about these in more detail, the AI models in Max are built from computational graphs that describe the intense calculations performed at each step through a model. We use a powerful graph compiler to optimize these models for the best performance on a wide range of hardware. At Modular, we write all of the high-performance operations that are the nodes in these graphs using Mojo, rather than relying on CUDA or other libraries. Mojo gives Max superpowers for squeezing the most out of GPUs and does so across a range of hardware. Now in 25.1, you too can write your own operations in Mojo in the exact same way as modular developers, programming GPUs or CPUs with an approachable Python family language and yet getting the most out of the hardware. We have new documentation and new tutorials for how to do this. Just go to docs.modular.com and dig into them today. We also have some fun new examples, and I'll show a demo of a couple of these right now. So I have a VS Code window connected to a machine with an NVIDIA L4 GPU up and running here. And this is all pointed at the examples that are in our current Max open source repository. I'll start with a very basic example, a hello world of GPU programming, where we'll take a tensor of values and we'll just add the number 1 to each one of them. To do this, we've constructed a very basic computational graph with a single node, and inside that node we'll place a custom operation that will run on our inputs and produce an output. And so we're doing this all using our high-level Python API so that we can go and easily interoperate with existing Python frameworks. As you see, we're going to run this on the first available Max-compatible accelerator, and again, we're going to be taking in a NumPy array, and we'll transparently convert that to a driver tensor. We'll move that driver tensor from the host to the device, and then run this calculation on a device and copy the results on back down. The actual operation itself is being defined in Mojo, and you can see here the code that we have defines the interface for this operation as we place it inside of our computational graph. What are the inputs? What are the outputs? But the actual calculation itself is very simple. It is the single function that we are running in Mojo that adds 1 to each element in the array. And why this is so simple is that we have a high-level abstraction in this for each function that, depending on what hardware it's run on, CPU or GPU, will automatically parallelize this calculation across all of the inputs, elements in the output tensor. And so it'll automatically self-optimize for the hardware that's available. All of this can be run using a single command, magic run addition, and that will compile the Mojo code, set up this graph, and run this calculation in parallel. And as you can see, the results match what we expected. Now we have more complex examples in an example that can calculate the full Mandelbrot set, and we have defined this all in Mojo code. Again, high performance parallelized calculation. We can do a magic run Mandelbrot. And again, it calculates out the full Mandelbrot set on GPU and runs that all right in front of you. We have even more complex examples that get into more manual GPU programming. We have an example here of a top K token sampler where we have 2 different paths, one that is optimized for CPU, one that is optimized for GPU, where we even get into some low-level primitives for going and doing accelerated GPU programming. And again, that full example can run using magic run top K, and it performs the full top K sampling. And again, you can see that it is running on our NVIDIA L4 GPU right here. Make it very easy for you to go and get started with GPU programming today. And again, all of these examples are available today in our Max repository. AI agents are incredibly powerful and are being put to use in more applications each day. In Max 25.1, we've enhanced our support for agentic workflows by adding constrained decoding, also known as structured outputs, to our OpenAI API compatible and serving endpoint. This means that we can ensure that generated responses follow a provided JSON schema. We also now support tool definitions and tool use responses, so AI models in Max can drive external functions such as searching the web. These features combined enable whole new agent-based workflows with AI models served using Max. To see these capabilities in action, please check out Hassan's excellent blog post on how to build agentic workflows in Max that is linked at the bottom of the slide here. To show the breadth and flexibility of Max, we've added preview support for multimodal models. We've added the Pixtral and Llama 3.2 Vision models, as well as support for other members of their model architecture families. These multimodal models can take in images and or text, allowing you to query the model as to what it sees in the image or perform more advanced image analysis and processing. The support for these models extends to MaxServe and its OpenAI API-compatible endpoints, which now serve multimodal models like this. These models are in preview, and for the latest, highest performance versions of them, I strongly encourage you to try it out on our Max nightly releases. Further expanding model support, Max can now accelerate the all MPNet base v2 model embedding model, and MaxServe now has a v1 embeddings OpenAI API endpoint. This lets Max cover many of the components of the typical retrieval augmented generation, or RAG, workflows. All Max AI models are now usable in a Python library-based interface within the max.pipelines module. This means that Max-driven models can be embedded in larger Python-based workflows or even experimented with in local Jupyter notebooks. When paired with our new embedding model support, this lets you easily perform batched offline inference, such as in the example shown on the right here. We, of course, continue to work hard to improve performance across the Max stack, from the compiler all the way up to the serving layer. At the model level, we've enabled page detention for Max-served LLMs, leading to a noticeable boost in serving throughput across each of our models when compared to Max 24.6. As a further optimization, we've put in place prefix caching, which can greatly improve throughput when encountering commonly reused prompts, like shared system prompts or repeated queries. At a lower level, we found ways to improve the compilation process for our GPU-targeted kernels, leading to noticeable reductions in compile time for GPU models. In some cases, we've seen up to a 1.5 to 4x reduction in compile time. Paired with that, specifically for NVIDIA GPUs, we do more compilation ahead of time, which greatly reduces the need for warm-up runs and gives you the best possible performance for AI models right away on the first run. To make it that much easier to get, run, and serve models with Max, we now provide a new command line tool called Max Pipelines that can be downloaded and installed with a single command. This means that you no longer need to clone the entire Max GitHub repository and build from there to get the latest that Max has to offer. You can now just use a single command to serve any model supported by Max on CPU or GPU using our stable releases or our nightly Max builds. If you visit our fantastic new Max Builds website, you'll find all the models supported by Max and easy instructions on how to run each using this Max Pipelines tool. And that isn't all. Max has also added model support for the Qwen 2.5 family, the brand new DeepSeek R1 distilled reasoning models, and more. Configuring values for serving has become much simpler, with GPUs auto-detected and used when available, and batch sizes and context window lengths automatically sized to available GPU and CPU RAM. For full details on everything released in Max 25.1, please check out the What's New in Max in our documentation. Try out our latest recipes, tutorials, and examples to see all that you can do with these new capabilities. We'd love to hear your feedback, so join forum.modular.com and participate in our ongoing discussions, share your experiences, and give us feedback as to what more you'd like to see in Max. With that in mind, I'll hand you back off to Caroline.
Thank you so much, Brad. Super exciting updates. Next, I'm going to hand you over to Abdul, who leads Gen AI engineering at Modular, to cover what's new in Mojo 25.1.
So hello, my name is Abdul. So I lead the Gen AI org here at Modular. And today I'm going to talk to you about what's new in 25.1. Now, one of the things that as we come out from 26.4, which is just about a month ago, was a question about what about GPU programming Mojo. So today, 25.1 marks the first release where you can actually do GPU programming Mojo and use it and execute it within Max platform. So we're going to talk about that in the next few slides. We're also going to touch about many new string-like optimizations that were added to the standard library. As we evolve the language, of course, we recognize past mistakes. So we are actually deprecating the borrowed and in-out syntax in favor of more kind of a unified syntax that we're going to talk about in the next few slides. The other thing is we're deprecating the named result type with these arrow T as foo syntax. Instead, you can actually now write in the arguments out foo, and that kind of unifies everything into one kind of cohesive syntax. There was a lot of, in prior Mojo releases, there was these conversion functions, bool, float, int, string, which converts, let's say, for the bool function, it converts from one value to a bool. We've actually kind of deprecated those in favor of using constructors. So instead of saying underscore bool, you say uppercase the B in bool, and that converts the type to a bool. That makes the code more succinct and easy to reason about. We've also added SIMD constructions so that you can cast from one SIMD type to another in a very efficient manner. Now, there's a lot of features in Mojo 25.1. I'm going to highlight a few, but I recommend folks to go to the changelog and read through the pages of changes that were added to Mojo 25.1. Now, I think most folks on this call or in this meeting are going to be talking about GPU programming with Mojo. And 25.1 marks the first release where folks are able to program the GPU within Mojo at both at the high level and the low level way. So we wanted to kind of explore these different, this entire spectrum and give people the tools so that they can program at low level as well as high level. So we've actually released a GPU package. You can go to the docs page and look at the APIs that allow you to manually manage and program CPUs or manage GPUs, and as well as the interaction between the CPU host and the GPU as well. This includes memory management, copies between device and host, synchronization, and more. Now, this is a low-level library. On the flip side, we also provide high-level kind of abstractions. So there's a new package, which is the layout package, which includes APIs to work with layouts. And what layouts are is a representation for thinking about things as how you index into a tensor. And this allows you to do very complicated indexing without worrying about the details that's done for you by these low-level programming constructs. And this can be used to build highly efficient tensor operations that run on both CPUs and GPUs. So it's not restricted to GPUs only, which is quite powerful. Now, there's a bunch of examples in the Max repository. I recommend folks to dig into those. But for now, we're going to highlight one simple example. So in this example takes an image, a 2D image, and adds one to each value. So first, I'm going to import the tensor slice from the Max Tensor package. And I'm going to import a few helper functions from the GPU package, and this, is to index into the thread index, the block dimension, and then the block index. So these are functions to give you where you are, to identify what thread you are at. And then we're going to define this GPU add kernel. So it takes an output tensor and then an input tensor. And then what this thing is doing is, for the x and y dimension, it computes which offset you're at. And then finally, it looks at, are you within bounds? And if you are within bounds, you're going to add one to the input tensor and store it to the output tensor. So this looks very, very similar to what you'd write in CUDA C++. It's just more Python syntax. Now, this is like just the basic examples, but the examples in the Max repo provides not only adding one to a tensor, but also computing Mandelbrot, so things that are not really AI related, to things that are AI related, like let's implement a flash attention, let's implement top K sampling, and so forth. So I encourage folks to dig into those examples offline. And by the way, this code will run on any NVIDIA GPU as well as AMD GPUs as well. Now, another thing that that the 25.1 includes is a lot of standard library changes. So there was a lot of changes. I'm going to highlight a few changes that were made to string. So first, the string type prior to 25.1 was kind of limited to ASCII kind of codes. We've extended that to support Unicode characters, which means you can put your favorite emoji as a string. There's a new also character type, which maps to a single Unicode character. So for folks that know Unicode, that means it's, the character type does not really map to a byte. It can map to 1, 2, or 3 bytes. So you can actually store any Unicode point in there. There's also an iterator so that you can iterate over these characters. So you can say strings.cars, and what that gives you is an iterator that you can operate on characters, the Unicode characters. This is not operating on bytes, it's operating on characters instead. Now, as we enhance the string character, what we've done is we extended the string slice to operate to work with lifetimes and being more kind of aligned with the string type. And as a result, it made the string ref type more redundant. So we've actually removed that in this release in favor of the string slice. So if you have code that's using the priorly unsafe string ref type, please move on to the string slice type. As also what I mentioned is we have new conversion functions from SIMD types to other SIMD types. So if I want to do a cast operation from, let's say, a SIMD of floats to another SIMD of integers, I could do that. But I can also do very efficient bit cast. So converting the bytes of a float SIMD type to a bytes of an integer SIMD type. That's very, very powerful, especially if you're doing low-level programming and you're trying to manipulate some bits. And then the other thing is the other thing that we've done is we favored construction methods over conversion methods. So instead of saying _bool as the conversion function from a type to a bool, we said instead of doing that, just use the bool constructor. So that means practically what that means is just making this b uppercase. And that's also super powerful because you can actually do a bunch of optimizations, and there's a bunch of optimizations for the string type that now this capital case string is able to exploit. Now, I've only touched it for a few kind of highlighted features in 25.1 for Mojo, but there's a ton of changes that have been made. I recommend folks to look at the changelog to examine the changes that are being made to 25.1.
Thank you, Abdul. Tons of awesome improvements to Mojo in 25.1. Finally, we're going to hear from Asan, a developer advocate at Modular, on Max builds and recipes.
Hi, I'm Asan. I'm happy to present Max builds and recipes today. Max builds is our new hub for generative AI models, application recipes, and community-driven packages. Starting in the models section, there are over 400 open source generative AI models and their quantized variants on CPU and GPU, including DeepSeek, Llama 3.2, Mistral Nemo, Qwen 2.5, and many more. You can sort models by model type, hardware, modality, and size. Follow the quick start instructions to serve models locally in just a few easy steps. After you're done testing locally, you can follow on deployment guide here to deploy your model to cloud with no code changes in a container with full GPU support. Max builds also highlights community-driven packages that are installable via Magic CLI. Finally, we head over to the Recipes tab to explore step-by-step guides to deploy GenAI apps using Max. You can filter by tag or difficulty level. Today, I want to show you our very first agent recipe. In any recipe page, first you will see the instructions for the recipe, details where you can get the code from, and the available tasks. You can run the app using Magic Run App, and once you're done, do cleanup. This AI weather agent is our very first agentic app that is meant to show you how you can use Max end-to-end to build a full agentic application using Max Serve. We do multiple LLM calls, and we also employ function calling to get real-time data and finally to generate the report. This particular pattern can be used in any agentic reporting automation, such as financial reporting, market analysis, recommendation, product recommendation, medical record summaries, etc. The first step to get started is to have all the requirements. And then after getting the code, you can simply run the application with a single command. You can also see the architecture diagram if you want to know more details about the backend and front-end architecture, as well as the request flow that is coming through the system. Now, let me show you how the app front-end is working. Let's take a look at the front-end view of our app. Because this is an agent, it has access to an LLM, which is Llama 3 here, and it can understand chat-like queries. And because it's an agent, it also has access to a bunch of tools. That means function calling, an API. In this case, weather data. So I can ask about a particular city data. Vancouver is the city I live. So what it does here is it analyzes the question if it's a chat request or if it's a weather request. And because this was a weather request, the next step is city name normalization. This is also important for later that we'll see. Next, the agent fetches live data and finally generates the weather reports, as you can see here. Another aspect of this app is we are not only using Max Serve with Llama 3, but also we are using an embedding endpoint for implementing semantic caching. What semantic cache does is it embeds requests and cache them so that if there is more semantically similar requests coming later, it can simply use the cache. So here we're going to test it with using YVR, which is the airport name of Vancouver. So as you can see, the weather report generated much faster in 19 milliseconds. If you're interested, we have technical deep dive on the backend and front-end code, as well as some performance optimization and observability that we've done. Last but not least, you can customize for your domain. You can take this code, run it, understand it, and apply the same set of techniques and patterns to your application. Thank you for watching.
Thank you so much, Hassan. What a great way to get started building with Max and Mojo. So now we're going to actually shift gears and answer any questions from the audience. So I'm going to welcome the team back on stage. And as a reminder, drop any questions you have for the team in the comments, and we'll get started with some questions from the audience. So starting with some questions from YouTube, we have a question from Leandro. Can we write and execute GPU code without MaxGraph as a custom operator like in CUDA C?
Yeah, I can handle that. Like I know this is a common demand and a common request. We're working on a great programming model for this. We've started with the Max graphs just because of we believe that, with our very powerful graph compiler, like it is the way you'll want to do like large scale compute workloads. And so we're starting from where we want people to end up, and the kind of high level abstractions we've built that right now like are very tightly tied to our graph compiler, and we're trying to expand that out into a more like eager programming model, or like one that is much more familiar to CUDA C developers. And so like, yeah, it is top of mind, and we're working on that. And keep an eye on the nightlies as we roll out more examples and more of these programming models, because we'll definitely have something to show about that very soon.
Thanks, Brad. Another question from YouTube. How will lowercase, bool, float, etc. work in def functions? Mojo was aiming to be a superset of Python, but now we can't use those.
I can take this one unless you want to, Abdul. So what we're trying to do is we're trying to make sure that we can provide compatibility, but we also get natively typed support to feel good. And so if Mojo has capital int, which is a very fast, efficient inline representation for people who want high performance. We also have objects that are like Python objects that are boxed and important for compatibility, but they're different things. And so before, we were actually committing a little bit of a crime in that we were using lowercase int, which is a Python thing, and having it return a capital int. And so now what we've done is just kind of move them apart. And so now capital int can stay fast and optimized and kind of Mojo native in that sense, but lowercase int is now can be the object thing and can provide full dynamic behavior and things like this as we build into it. So it's actually a good move for compatibility. It's a good move for performance. It's a good move for consistency. And so we're pretty happy about this overall.
Thank you. This was submitted by the community. So as Mojo has abandoned the narrative of being a Python superset, could you reconsider language consistency and make the whole standard library in snake case?
I'm happy to take that one. I think it's totally something that we can consider in the future. I think one of the things that we leaned in on initially when building out the standard library is familiarity. And given that our target users were coming from Python, it was very familiar to them. And so we tried to maintain consistency where applicable in that regard. But going forward, I totally think it's something that we can consider.
Thank you. We have some other questions from YouTube. Dear Modular, should we be expecting an FPL this year, 2025? And I'm told that FPL stands for Foundational Product Launch.
I don't know what foundational product launch means either.
I'm not sure either, so maybe that person can clarify. We're not exactly.
Okay, so how about I give you a general answer? Sorry, I'm not up on all the cool 3-letter acronyms, but kids these days, whatever. 2025 is huge for Modular. Like, this is a really big year for us. Like, just zooming out, we've been cranking away for 3 years, building really obscure foundational tech. So I don't know if that's the F, but and we're working on these like low-level things that very few people understand. Right, and it all builds up to something really cool. And just at the very end of last year, we had our first GPU release, 24/6, right? And so that was very much the beginning, but it was also obviously just like the earliest possible proof of life. And so 25.1 for us is another huge step forward where we enter the world of agents, and then we're like suddenly we're like bringing all of this technology together in a way that is really profound. So what you'll see across even next month and the months ahead and all these things is like more and more and more come together. And at the same time, Mojo is like growing up, it's becoming a real language. One of the things that, again, it's not obvious outside, but a lot of the folks working on Mojo have been working really, really hard to enable GPU programming, to enable productivity. So one of the funny things about Mojo is that one of the beautiful things is that it's used by the Modular team for pretty much everything we build that runs on a GPU. And so this means that, I don't know, Abdul, you can comment about this. It turns out that things like compile time are really important. Like, it turns out that, just in the last month, there's been almost a 2x improvement in compile time. And so we can build things way, way, way faster than like CUDA, for example. And so this is what enables the platform to go really fast. And the problem from a changelog perspective is it's not like a new fancy syntax feature or something that people would understand. And so what I think you'll see from modular across this year is you'll see a shift as we're getting these foundations in place to now we got our homework done, we can go out and play. And that'll be at the Gen AI level, that'll be at the language level, that'll be at the API level, that'll be at the hardware compatibility level. There's like all this stuff that's opening up in front of us. I don't know if anybody else wants to add anything.
Yeah, I want to just mention that, if you rewind a little bit to 24.6, which again, I'm going to remind folks was about a month ago, I think Llama 8B used to take like 3 minutes to compile and run. Today it takes 30 seconds the first time, and then once you compile it once, it takes 3 seconds. Obviously, we are actually continuing to improve that. We want to have the experience of you can run the model in kind of sub-second. That's kind of our North Star goal. But that means a 10x speed up, and we're progressively working towards that. The other thing I want to touch on is the GPU package is the docs are up to date. They're up there. We are slowly adding examples. This is, by the way, the same exact package that we write to all of our kernels. It powers all of Max and so forth. So you can actually write high performance kernels that run and compete with us as well. That would be very, very exciting. We can learn from you. The other thing, by the way, the final question I have is, while it's like enticing to have folks want to have GPU programming outside of MaxGraph, MaxGraph actually solves a lot of problems that you have to worry about if you were to write kind of standalone GPU code. So things like memory management and other kind of optimizations that you'd otherwise have to worry about. Usually folks are kind of interested in implementing their core algorithm. They're not interested in how they shuffle memory around and so forth. And what MaxGraph gives you is like you can concentrate on implementing your vector add or flash attention or some other method, and you don't have to worry about memcopy here, memcopy there, and so forth. And that's the reason why we started with the Max as custom ops. But again, you can write any custom op. We put in Mandelbrot, which is clearly not an ML application.
I think Mandelbrot's really to flex and show generality, right?
Another question from YouTube. Please tell us, when can we start porting Python libraries into Mojo?
I'm happy to take that one.
Yeah, Joe, do you want to talk about Python Mojo interop and kind of the progress so far and how it's coming back and things like this?
Sure. I think there's two aspects of the question. One of them is, when can I start taking these existing Python libraries and start building out the Mojo ecosystem? And you can, of course, do that at any time, and it gets easier as we build more into the Mojo language and the ecosystem and APIs and that sort of thing. It takes work, though, right? Some libraries are quite big, and so you may want to lean into more code generation or automated tooling to make this easier. The team has, begun work quite a few months ago on Python interop. So this is the ability to basically bridge from Python code into Mojo code and allow projections onto that, and communicate types across the boundaries and that sort of thing. We're not active. That is not our active highest priority, given the internal work going on with GPU and bringing that forward to the world. But it is something that is something that we're working on internally. We just don't want to commit to any external deadlines right now.
Thank you.
I'll also add that we're exposing Python interoperability in other dimensions as well. We've invested very heavily in Python APIs for Max, so you don't have to rewrite the world to incorporate Max into your gigantic Python code base. We have like zero copy interoperability with our Python driver tensors and PyTorch tensors, as well as NumPy arrays. So you can just drop in Max into existing Python code bases from those APIs as well. So we're trying to allow you to progressively adopt Max in many places as possible.
Exactly. We're bridging the gap in other ways, like Brett said. So your entry point can be familiar with the Python Max Graph API, but all of your custom op is powered by Mojo.
Awesome. Any plans to explore model context protocol support for Max?
This is a very good question. I think we are working on it. I don't know about any particular plans, but yeah, this is a very cool topic. Yeah.
And please, if you have feature requests for Max, like go to our GitHub repository and file an issue with a feature request for it. We'd love to hear your applications.
Thank you. Maybe y'all have done this already, but are you planning to upstream the debug info dialect you showed at Euro LLVM 24? A deep cut.
Hey, Ian, it's good to see you. I don't know if we have. I don't know if there's anybody that's pushing on that right now. If you ping us in one of the channels, we can just give you the code if you're interested in upstreaming it. Because I think there's really two things. It's, do we have time to do the work to do the upstreaming versus do we want people to have access to it? If you're interested in helping with that, because I know you're an active MLIR person, like, let's work together. Let's just do it.
Awesome. I can give my answer for this one, but we'll also let other folks chime in. Are there any areas you'd like to see more activity, contributions, or even simple exploration in from the community? One area we'd love to see more participation is our community packaging via Magic. We recently enabled folks in the community to start actually distributing their own packages via Magic, which is our kind of bespoke package and environment manager. And so that's really the best way to share projects that you're building on top of Mojo and Max. And we'd just love to see more projects shared throughout the community using that mechanism. So we'll share the link to that GitHub repo and the instructions for that in the comments as well. But that's something that stands out to me, as we'd just love to see more folks participate in that. Any other areas that anyone wants to add?
One other area I'd love the community to start playing with is as we're starting to come forward to the market with custom map programming and GPUs and releasing docs for GPUs and layout tensor. Go play with it, read the docs, ask us questions. Sometimes when you're too close to this stuff, you're not as good as explaining it to, like, if you're the first time using something. And so we definitely value feedback and would love to iterate on it with you. And whether that means go try and implement the latest, flash attention kernel using our custom map machinery and then do competitor analysis. Like, we'd love to see those kinds of things.
Yeah, absolutely. Just like let us know what is painful, what is not a great experience for you. Let us know in the forum.modular.com. And also let us know what other kind of recipes you'd like to see. Hassan did that awesome demo. We plan to open that up more to the community. So definitely let us know what you'd like to see there as well. Are different types of deep learning models, such as recommender systems, on the Max roadmap? From Leandro.
Julie, you want to take it? I know there's a bunch of stuff coming. So.
Yeah, there's a bunch of things coming. DLRM and other types of models, you should be able to run it. One thing is that we have is, while we have Max Graphs, which is kind of our signature performance models, the showcase models, we support all the PyTorch models that are out there. So folks can go to builds.modular.com. If there's actually I'm not quite sure if there's a recommender model, but you should be able to go to get Hugging Face and just run any Hugging Face model through our PyTorch stack.
Yeah, and the other thing I'd say is that if you're a model builder, if you're familiar with how models get put together and things like this, like using Max Graphs to explore that, I think would be really cool. And if you're interested in exploring building DLRMs with Max Graphs, we'd love to see that work and see what you can come up with. As Abdul says, I think that we have everything now, so that it should actually just work. I just don't know if somebody's done that with Max Graphs.
Yeah, and if you want sample code
and also recommenders are like super a huge space of really cool stuff, widely used, and so that would be really cool to explore.
Yeah, I mean, to follow on what Chris is saying, if you want to look at our current implementations of our LLMs and other models, all of that source code should be available in the Max repo. It's within the max.pipelines module. And so we have like core architectures that we've built up there. So take a look at the abstractions we've built and the models we've built in Max graphs there. And you should be able to like start being able to port that across to different model architectures. And we'd love to help if you're working on that and you run into problems, just let us know. We'd love to expand the documentation and examples there.
Thank you. Any ETA for re-rankers?
I can take this one. Also, great question. I'm not aware of any ETA. Please file any feature requests in our forum or GitHub like that. Yeah, it's definitely something that we want to do, but we don't have a particular plan for it now.
Yeah, I'm not a super expert in re-rankers, but but this is also be really fun for people to explore. And I mean, this is something where building packages around these kinds of models, these kind of techniques, and showing off what you can do is fantastic. If we can help amplify your work, like that's something that we'd love to see.
Yeah, one thing is also like the recipes. So if you go to builds.modular.com, there's a lot of recipes. You can actually take a RAG application and probably extend it to be a re-ranker and contribute it back. You know, we'll probably be happy to accept contributions.
Thank you. I think that's actually all the questions we have for today. So thank you to the audience for the great questions and for tuning into today's event. Be sure to share any other questions that might come up in our forum at forum.modular.com. The link should be on the screen there. And we will see you next time.